Hi everyone, welcome back to the channel. We are back again with another semiconductor industry professional, Kailash Prasad. Kailash is a PMRF, Prime Minister Research Fellow at IIT Gandhinagar. He completed his PhD in electrical engineering and is working in ARM currently. So he's also passionate about teaching VLSI and microelectronics to students. So let's take this opportunity and hear it from him. So over to you, Kailash. Introduce yourself, please.
Okay, thank you, Swati, for inviting me. Uh, all the informations are correct, actually. So I'm currently a design engineer at ARM Embedded Technologies Private Limited. Prior to that, I was a PhD scholar at IIT Gandhinagar. I am yet to defend my thesis. Okay, so so technically, I have not completed my PhD. However, I've submitted that. Um, Apart from that, just few information I want to share. I did my BTech from NIT Arunachal Pradesh, right, far northeast, and I have done my BTech in electronics and communication engineering over there. And after that, I directly joined PhD at IIT Gandhinagar, right? Few information about that because it's a PhD directly after after BTech, right? So that's not so easy usual, but currently actually it has become a norm in India. People are doing PhD after BTech, and why IIT Gandhinagar? It was a very special institute because they have this start early PhD program where what they do is they hire BTech from top institutes like NIT, triple ITs, right, and select institute right after BTech. So the interview happens in 7th semester itself, and there are monetary benefit also. They pay you 10,000 extra, right? So that's how I got into the PhD program.
So, like early PhD, as in it's called early PhD because you would have not even completed your BTech completely and you start the PhD program, or how is it?
Not really. So the interview happens in 7th semester. Typically, the PhD interviews happens in the 8th semester, right, around April, May. But I have given an interview in my 7th semester, so it was like in October 2017, if I remember it correctly. Right, so that's the reason they call this as early PhD. There are early MTechs also, early MA, MSc from IIT Gandhinagar, and this is a very unique scheme, right? So the thing is, you do not have any gate requirement as such. However, if you qualify gate, you will get additional 10K fellowships in case of PhD. If you are an MTech, I think you will get additional 3,000 apart from whatever MHRD is giving to you.
So, like, it's a big commitment, right? Starting an early PhD. Like, what made you motivated towards it? You're always going for research, or it is something that you're passionate about, or what is it that made you take this early
Okay, so
PhD?
yeah, I have to say the truth, right? Okay, so the scenario was a bit unusual or maybe tricky from my side because I was actually placed in one of the PSUs in my BTech. So it was a pool campus which happened in NIT Meghalaya, and yeah, I was one of the very few candidates who got selected. Uh, Apart from that, I also had an offer from IIT Gandhinagar in the 7th semester itself. So one day I decided that okay, let's, because the joining date of PSC was in December, right? So I thought that okay, let's join IIT. Okay, and let's see what happens over there. That kind of thinking I had. But when I joined IIT Gandhinagar, this is NanoDC Lab I am talking about, Nano Electronic Devices and Circuit Laboratory, which was headed at that time by Professor Joyce Meki and Professor Nihar Mahapatra, right? I joined under Professor Joyce Meki, and this lab was very special because in my BTech, I have never experienced that kind of research which was going in the lab, right? People are working in different sorts of technologies and all. One of my mentors were working on approximate computing, very fascinating, right? As a BTech, you just read, right? Here, people are doing research. Apart from that, there are other people, seniors, they were working in 3-5 semiconductors. Then I think, if I remember it correctly, one of my senior was working on this, what you say, right? The advanced transistors. You see FinFET, the nano sheets, right? So they were working on that. And whenever they used to talk about this thing, right, I was naturally inclined to get into the discussion, right? This was, I have never experienced it before, right? So that was the time, okay, I have taken this decision that, okay, I will not continue or go to PSU, right? I will continue the PhD, right? So this decision actually happened in around October or November, where while I was in IIT. So it was not like that, okay, I was very, what you say, inclined toward research, right? Although I was in my BTech, I used to do a couple of VLSI stuffs with one of my professors over there. But it it actually started after joining into IIT, right? So that's how my path is different as compared to, if anybody you will see currently, people are well informed as compared to what I was in my BTech in 2018.
Okay. So mostly like people when they say research or something, no, mostly they go abroad to do a PhD or MS in research or something like that. So currently, I heard many people say that India is also giving many opportunities for research, but very few people know about it, or very few people actually take this opportunity. So, do you want to share anything that is motivating people to actually do research in India instead of go abroad or something like that?
Yes, yes. So that's, I think, one of the very important question I wanted to answer. The thing is, the scenario is India is now different as compared to what it was, say, 20 years ago. The thing is, I think I have read one report from Professor Udyan Ganguly from IIT Bombay. It actually says that the nanoelectronics research, right? So it's on devices. India ranks third. The IIT system ranks third among the world, right? So after MIT and I think one of the universities, the combined IIT system ranked third in terms of publications, the patents, and representing IITs in top conferences and all, right? So that's not something small, right? That's huge. That's what I was talking about nanoelectronics when we talk about devices. However, in terms of design and circuits also, we are doing pretty good. There are, I think, ample examples. One of the few example is Sakti Group, Sakti Processor, everybody knows about from IIT Madras, right? Neil Gala and his company is there. One of the example I want to give you is one of my fellow mates, Ankita Nandis. He was my batchmate at IIT Gandhinagar. He joined IISc Bangalore as a PhD, right? And Aryabhat is one of the chip they have designed, right? So he's one of the co-authors in that, and that chip is also one of the first of the kind neuromorphic chips, right? So the thing is, people are doing ample amount of research, and when I talk about my lab at IIT Gandhinagar, we are doing a lot of things like in-memory computing, approximate computing, and this is actually this holds true across India, right? People are doing a good amount of research, publishing in top conferences and all, right? And I think the government is also at now, I think from last 2 3 years, have a very high push in semiconductor research system and all, right? You might have heard about the news of AMD setting up largest research center in Bangalore, and this is very few examples, right? So the thing is, if you have to take a decision, right? Again, that's a personal decision. I do not want to enforce anything on that, but India is currently one of the best choices to do PhD over here, and the opportunities are very huge if you join PhD in VLSI domain. So this was just in terms of a research perspective. If I talk about the funding perspective, PMRS is one of the schemes, right, which actually provides you this what you say, right, a very huge monetary fund. When you compare to India, the stipend you get is, I think, on par with the professionals, right, while doing PhD itself. Apart from that, there are various other fellowships, right? MSR fellowship from Microsoft Research, Intel fellowship. I was one of the Intel fellows also, and Intel, they actually fund you, and there are various other companies which are funding now the PhD fellows in India, right? So the thing is, the research landscape is changing in India, right? You can consider India as one of the potential what you say venue to do PhD.
So, like when a company is funding for research, is it like you'll be working on a company project, or will you be working on something that company is interested for pursuing in future? So you hand back that once you've done the research, or how does that go about? The
Okay, okay,
institutes are still
that's
fine; they give funding because it's a institute kind of a government fund. So how does the
yes.
company funding work?
Okay, so if I take the example of Intel fellowship, so the thing is you have to write the proposal to the company, right? Okay, this is what I want to work on. So it's not like that. Okay, company will have a broad spectrum of domain in which they want to what you say invite the fellows. However, you have to write the proposal. In my case, I've written in-memory computing only. It was the PhD proposal which I was supposed to work on, right? And in that, what happens, the best thing about this industrial what you say fellowship is you get to start working with the guidance of an industrial expert along with your guide, right? So in my case, it was Intel Processor Architecture Research Laboratory from Bangalore. So I've been working with them for 1 year during the fellowship duration, and I've been working after that also, maybe after 2 years, because we were also part of this SRC program, right? My guide has this project, and because of that, it so happened that during these 3 years, I've been working with Intel, NXP, and the professionals from them. When I say working, it means that I have been working in our whatever the projects we have proposed. They are the what you say the guiding the people, right? So they will actually tell you that okay, whatever you're doing is correct or not, right, in terms of industrial perspective. And they also will tell you that okay, these are the some things which industry is looking to, right? So you may want to look into that also. This is how an industrial fellowship works.
So for people who don't know what is PMRF, we'll actually put the link in the description. It's a Prime Minister Research Fellowship, and it's kind of a grant of more than 2 lakh per year, I guess, about for research. And yeah, for more details, I'll just put it in the description. So Kailash, could you share how, like a roadmap or some strategy or something for people looking forward to get this? Because for when you go think about research, many people get set back because of they'll not be earning in that time and things like that, right? So this is a major boost in that sense. So
Yeah. Okay, so getting a PMRF is not a straightforward thing. Okay, so let me tell you the procedure and how I get into the PMRF scheme, right? So when PMRF was launched, I guess in 2018, right, I was eligible from day one because I have done BTech from NIT and I was one of the top students. Um, However, the thing is, I have not applied PMRF till 2020, right? In 2020, what has happened that the procedure how PMRF fellow will be selected actually changed because it was under, I think, the IIT Delhi was conducting the PMRF at that time, and the procedure is now is like this. Okay, so you have to get into a PMRF granting institution first for a PhD. Okay, so that's the must, and these are all the IITs, IISER, and I think couple of institutes which actually ranks under NIRF 10 ranking. Okay, and after that, what happens that there are two channels through which you get the PMRF. The first one is a direct entry. The second one is a lateral entry. Right. In the direct entry, what happens that the institute will nominate you right after your interview, right? And the first screening happens at the department level, right? So department will nominate their top few guys, right, 2 or 3, and all the department will now nominate, and it will go to the IIT, the academics, right? And then academics will nominate few, depending upon whatever the number of seats that has been assigned to that institution, right? Those number of seats will directly go to the PMRF conducting institution. In my case, it was IIT Delhi. And after that, the IIT Delhi will actually nominate few of them, and then okay, then the final decision will come up. So it's a multi-level process, right? So this is what direct entry, and the process remains same in lateral entry. But what is different over there that you get into PMRF granting institution. After that, you work for a year, right? If you're a BTech, you have 2 years. If you're a MTech, you have 1 year, right? And you do excellent work over there, right? So in that 1 year, in terms of coursework, right, if you can get a couple of publications, right, that actually adds to the benefit, right? And then you apply. Okay, and the same procedure happens that okay, department will select a couple of them, and then the academics will select, and then it will go to the PMRF conducting institution, and you will be selected on the basis of that. It's a very tough process, but the thing is, if you are good, right, so you will get there is a very high chance that okay, you will get selected. Okay.
So it's like, do you have to give a proposal on module research before getting the funding, or they just give the funding based on your performance, and then you can later decide on what you do with the funding?
Okay, so in direct entry, you just have to give an SOP that, okay, this is what you have done over your, what you say, till your BTech or MTech, whatever you're applying for. And for for lateral entry, the thing is you have to actually give a proposal that, okay, this is what I will be working on. And okay, this is my SOP also. So you have to give that, and this is how I am good, right? You have to actually prove in the SOP. And if you have couple of publication, actually it adds it gives you a very high chance, right? So I had two publication when I have applied for PMRF, right? In that case, my candidature was very strong in that terms, and I have very many examples for that. One of example was the Ankita Nandi I was talking about at IISc. So she has, I think, 3 or 4 papers at IIT in MTech. Okay, so when she has applied as a direct entry, I think she got PMRF fellowship. And this holds true for our students also. So many of our MTech students at IIT and BTech students, they join PhD at IIT Gandhinagar itself right now because of this PMRF scheme. And because you have done a good work over there, right, it becomes favorable to you that you will be considered for PMRF because you have a BTech from IIT, right? And if you have an excellent academic profile, right, so your chances improves. So this has actually changed the scenario, right? Earlier, our all the gold medalists and all used to go abroad and do PhD. I have few examples at IIT Gandhinagar itself. They have joined PhD there and there itself, right? All the president gold medalists joining IIT, your institute, right? That's a proud moment, right? And PMRF is helping you that, okay, you retain your best students in India itself.
So like your research was on like materials and microelectronic based, or more on the application side? How, what was your major, like if you could share a
Yeah,
brief
yeah,
on
sure.
what you did on, because I think you did something on AI and ML, right? Hardware for AI, something like that. So
Okay, so if I summarize my research, is domain-specific hardware design for AI and ML, right? So that's how I summarize my research, right? So I'm basically a circuit designer, right? When I talk about circuit designers, I don't work in the design of devices. Rather, I work in the design of circuits, right? One of the domain I worked on is in memory computing, right? So in memory computing is one of the very hot topics which has been going on for past 3-4 years, and the idea is to remove this what we call as von Neumann bottleneck. Okay, what happens that, okay, you have a CPU, you have a processor, memory, right? And there is a huge data transfer between the processor and memory, and it becomes a bottleneck, right? Because your interconnects are not that great, right? So the idea is now currently memory are dumb unit. Okay, so it just do the storage. It doesn't do anything with the data. So we are trying to make memories more intelligent and try to compute inside the memory. That's one of the topic, and it's a I think significant chunk of my PhD. Okay, this is what we work at IIT Gandhinagar. And after that, I have also worked on approximate computing. The idea was to make our compute circuit approximate for the applications which doesn't require too much, or what you say, right? Which are error tolerant, right? And AI and ML applications are very error tolerant in that regards. Apart from that, I have also worked on what we call as physical and colonial functions, right? So this is security aspect of it. So we design hardware primitives which can actually be used for security. Okay. Apart from that, these were what I have done as a part of my PhD. Apart from that, I have also worked on automating the analog design, right? So this project was done with one of the other professor, Professor Nihar Mahapatra. And the idea was, okay, we have this RTL to GDS flow for digital design, very beautiful flow, right? We do not have for analog design. Can we use machine learning to make sure that, okay, we have this tool chain, okay? So this was the design perspective. In apart from that, I have also designed simulators and all to do application level study, right? So you design a circuit. Now the thing is you want to see the performance at the system level. Okay, so I have one of my colleagues, now he is in Germany, right? So he was doing PhD with me, and he used to design this application level simulators and all, right, which can actually map neural networks directly. And I will give the circuit values and all, everything, and it will actually give you that, okay, if you design a hardware accelerator as a whole, right, how much benefit it will give, right, with all the approximate designs, operating designs I have designed, right? So we have worked right from circuit level to the architecture level, right? The design is digital, mixed signal, and analog, all of them.
You've got experience in a wide variety of roles within the VLSI industry. It's really great to get to work on so many different things in such a short span of time and do something significant. Like you've kind of gone deep into many of the parts, right? And you've been able to contribute to design in all of these parts while doing your PhD. It's actually really good to listen to it too. So I
Yeah.
just heard most of the things you said, like memory. You said about enhancing memory performance and about security. All of these you said it with regards to AI, right? So right now,
Yes.
everywhere in all industry, AI is the thing everyone's looking forward to. Like if you could do anything that enhances AI ML performance, is what every industry is going behind. So what do you say for anyone? What do we have to learn, or what do we have to do to keep up with the trend? Like most research is
Okay.
also going in that direction towards AI, towards making intelligent chips everywhere. So for someone who wants to keep up with that trend and do something in that domain, what do you think we should start with?
Okay, okay. Yeah, so AI is everywhere, right? So I have attended, I think, Design Automation Conference. DAC is the largest conference in EDA in 2022, 2023. Then I have recently attended, I think, ASP DAC, DATE, and VLSI Design. Everywhere, so there are, I think, one of the statistic in DAC, they have shown that, okay, 50 to 60% papers were somehow related to AI, right? Although it's a circuit design and automation conference, right? So AI is everywhere. The thing is, so AI is actually proving to be a game changer for all the industry. It's not only about the computers and the IT or the semiconductor, for all, right? AI has been applied everywhere. For example, agriculture, right? For example, healthcare to detect the diseases and all, right? So the thing is, because AI is so powerful, right? So you want to design hardwares, right, which can support AI, right? So that's where the semiconductor industry comes into picture, right? Because you have to run AI somewhere, right? And there are a lot of problems in that, because these AI models are very energy hungry, right? So the power, they have a very stringent power requirement, they have very high power requirement and all. And if you want to run this AI model in the edge devices like mobile, or it's not feasible, right? Your battery will drain down in a fraction of an hour, right? Which was supposed to last for a day, right? So that's where this specific chips which can accelerate AI are coming into picture for edge devices, and also for the server class also. We want our so we have GPUs from NVIDIA, right? So those are the benchmarks. But people are going for designing their own custom chips, which can accelerate AI more efficiently than NVIDIA's chip. Okay, so people are designing hardwares for AI. If you want to get into this AI domain, right, the first thing is you have to look into what's been going on across, right? And how do you look into? So you look through the proceedings of these top conferences like Design Automation Conference, right? ISSCC is the Circuit Design Conference, the top one. Then we have a ISCA, right? International Symposium on Computer Architecture, right? If you look into these 2, 3 conferences, right, and the papers on this, you will actually get to know, okay, what's been going on, right? And on the basis of that, what you can do, you can start, okay, you read first, right? The first thing is always the reading, right? You give a month or two to read all the aspects of it, and then whatever the topic you like, you get started with your research, right? So this is one aspect where we are designing hardware for AI, right? The other aspect is AI being used to design hardware, right? The analog topic which I talked about in earlier, right? So that was the second domain, right, where AI has been used to design analog circuit. uh, couple of companies, if I name is Synopsys, right, Cadence, and this Mentor Graphics, or Siemens currently it is. They are including AI in their tool chain, right, in order to accelerate the design process, right? So AI has been used to design hardware, and hardwares are designed to accelerate AI, right? It's a both-way street, right? So you may want to look into what you say, right? This proceedings and all, right? And on the basis of that, you get started on doing the research.
Uh, like when you do a research on the first, when you were saying you did research on design, right? How to design the memory for better compute. All these would be kind of a simulation, or it would be sent for as a chip, like to get the taped out chip to verify it, or how would it be in research? I don't have the
Oh,
idea of how much level you could end up after doing the research. So I'm just asking
okay.
you.
Okay, so at IIT Gandhinagar, so we always start with the simulation result, right? So the you design, say, if I talk about in-memory computing, so the tool we use is the Cadence Virtuoso, where we design our memory arrays, right, with all the peripherals design, like sense amplifier, write drivers, and decoders, all the logic we will design, and then we will do the first level simulation, which we call as schematic level simulation. Then what we will do, we will design the layout, and we will do the layout level simulation. That's the second stage, right? And then we will actually design the entire chip in the layout itself, right? And we have actually sent two chips for fabrication at IIT Gandhinagar. IIT Gandhinagar is one of the very few institute which actually sends the chip to fabrication, the digital design chips to fabrication, right? You will see everywhere people are actually sending fabrication. In India, I'm saying,
Mm.
the analog chips, but in terms of digital design, we are very few, one of the very few institutes which actually sends to the entire tape out. So we design the full chip, and then we send to the fabrication, right? This fabrication happens in 65 nanometer technology to 28 nanometer technology. And after that, we receive the chip, we will do the manual testing, right? If everything is working fine or not, right? It happens so that in duration of my PhD, I happen to lead two of the tape outs in 2020 and 2022, along with my guide, right? So, yes.
That would really feel proud, like you got your entire chip designed and you can see the chip coming out. And like usually when we work in college in BTech and all, we do design tasks and everything, but mostly stop at simulation. At the max, go to some FPGA. But having it taped out on a chip and working on it is something of pride. You can say that I designed this chip and you can see your chip.
Yeah, the chip has
That
to
feels
work
good.
as per expected, right?
Yeah.
But yeah, having a tape out experience itself becomes a very huge thing, right? And that's why I think the one of the your earlier question, right, doing PhD in India, right? Yes, it makes sense, because as IIT Gandhinagar is sending, there are various other IITs which actually sends the chips for fabrication, right? So if you get into one of this institute, right, you will actually get some hands-on experience of full RTL to GDS flow, right? And trust me, it is one of the most valuable skills you can have as a VLSI engineer, right? To have worked in the full flow, right? Even if you go in an industry, you won't get that kind of expertise in your initial years, right? Or exposure in your initial years, right? But at IIT, what happens is that
In
yeah,
IIT,
yeah.
doing
So
the research.
yeah, at different IITs, we are now actually doing the end-to-end tape out. And one of the schemes from, I think, government which has recently started is SMTP C2S, right? So the thing is, they are what you say, they want that you take the design and you build a full product itself. So not only the chip, right? So they expect you to build full products, right? And I think most of all of the IITs are actually part of this SMDP C2S program, and various other institutes also, right? So if you get into any one of this institute, right, you will actually have the kind of experience in the full RTL to GDS flow, right? Which is the most valuable skills in the industry, right? As a PhD, if you get this experience along with the research experience, right, it becomes extremely valuable.
So how do you think like your research or your PhD experience did play a major role in getting placed in AN or getting into the industry? Do you think any
Yes,
of
yes, definitely. Yeah, definitely. The thing is, the topics which I have worked in my PhD was extremely aligned with what industry does. So I have So the current role which I'm working is a memory design engineer, right? So when I talk about memory, this is SRAM, right? So, and in my PhD, I think for 4 years or 3.5 to 4 years, I've invested my time in memory design, and the interview process, if I talk about, was right. So whatever they were asking, I have already done in the PhD, right? So and one of the reason behind that is because I have been working with industry during this 3 to 3.5 years, right? And we had various inputs from the industry directly there and there itself, right? And because of that, whatever the nuances which was required to make our chip more industrial, to go to more industrial standard, right? We had because of this our this industrial partners. So and in my PhD, actually, I have majorly focused on working on those type of topics which are more relevant to the industry when I talk about the memory design, right? I have explored each and everything which can come as a part of memory design block. Okay, so it becomes extremely useful. So when you give an interview with this level of understanding, right? So they appreciate that, right? They have a deep respect of the knowledge and skills you have acquired during the PhD. One of the few incident that has happened that, okay, people were not expecting to have that kind of understanding of the memory design despite being in an industry, right? And you get those kind of exposures now at PhD, right? Because you are working with so many people. And one of the things I want to put out is it's not the knowledge which I have acquired, which has reflected in the interviews or the end. It is a combined effort of a huge team, right? So I have never worked alone in my PhD. Okay, so that is some kind of philosophy I have, right? If you want to do big, you need to have a big team, right? So my guide was generous enough to allow me to work with anyone whom I wanted, right? So that's how I have started working with BTechs, right, from MTech students and the PhD students. If I say a ballpark number, roughly 60 to 70 students I have worked on from IIT and outside IIT as an intern, or you say project staffs and all, right? So whatever knowledge I have gathered is not my knowledge, right? So it's the combined knowledge of the entire team, right? Because if you work with so many people, everybody has different perspective to look into it, right? And we can actually cover a wide spectrum of topic because of that, right? And this is not a general trend in during the PhD, but that's what believed and I have followed, that okay, if you work with a large, so it becomes difficult many a times, right, to manage so many people. But the thing is, if you want to explore wide variety, get into deep of those wide variety of topics, you need extremely well trained people, right? So the idea was first you train them, right? So we have a few courses like VLSI design, CMOS IC design, where we actually teach the entire flow, right? And this happens in industrial standard tools, right? So they have that level of understanding. And the tape out which I'm talking about, right? So it's not like that I was the only one. It was a team of 15 people, okay, right, from BTech, MTech, PhD, right? And IIT is one of the very few institutes where BTech has participated in tape outs, right? And trust me, these are BTech second year, third year, and fourth year students, right? People do not expect them to have such detailed level of understanding in VLSI design, right? But at IIT Gandhinagar, our BTech students are on par with any MTech and PhD who are doing in VLSI design, right? Because they get into and they start associating with our lab in very initial years itself, right? And they continue working for 2.5 years, and that kind of experience which they get, right, in 2.5 years, right, becomes very useful to us also. And when they apply for industry, they are already industry ready, right?
Yeah, I
So
totally agree.
whatever.
If you get more exposure in your early years, is way better than doing mediocre and following the trend, and then later on finding to know that you have not got exposure in most of the aspects of the industry. So it's
Exactly. This suggestion I have for everyone, right? So if you are at any IIT, right, or top institution where this kind of research are going on, and you are a BTech student, right? in electrical or electrical related domain, you just get into and you associate with the lab, whichever lab which is doing VLSI, right? Or whatever domain you want to work on, right? It's not only about VLSI. You get associated with the lab, right? And start talking to your professors, PhD scholars, that in the very early years, right, from second years itself, right? Then you will get more exposure, right? And you can do a good quality projects, right? And it can result to publications also. Our BTech students, we have at least one or two publication, whoever has associated with the lab, right? Not at normal venues, at the top venues like design automation conferences, right? Date, ASP DAC and all. So this suggestion I have for everyone, right? And if you're not in that kind of institution, try to get internship at IITs in your second year, third year. Have a very good academic profile, right? Because obviously grades do matter, right? It's not like grades are not important. Grades are important to just cross the entry level barrier. But after that, your knowledge actually starts coming into picture, right? To try to have a good academic profile and try to apply for internship in academia and industry in your second year and third year itself, right? And for that, you have to be well prepared ahead, right?
Thanks a lot for agreeing to share your experience. It was really nice
Yeah.
talking to you,